Dear students, this is Mr. Muhammed Azeez. In this video, we're going to start Chapter 5, Section 1. Chapter 5 is about integration. Section 1 is about indefinite integral. And Section 2 is about definite integration. As you already know, I posted 5.3 earlier. Now let's begin with 5.1. Integral means antiderivative. The process is the opposite of derivative, but we don't really depend on derivative. Just do integral. Take integral as a new topic. Do not always think of finding a function whose derivative is what's inside the integral. No, this takes time. The first rule of integral is whenever you see x with power, then we say power plus 1. This 2 becomes 3. Divide by the new power. So this is the first rule of integration. X with power will be power plus 1. This power 2 plus 1 will be power 3. Then over the new power. When I say power plus 1, I will get x power 3. I should divide the whole thing by the new power. The new power is 3. And there's always plus c. For the exam, this plus c is not a big deal. Integral of 0 equal to c have been in Wizari multiple times. It's just a rule. Integral of 0 is c. C means any number, means constant. And the opposite process, derivative of c, derivative for c is equal to 0. Integral of 0 is equal to c. So derivative and integral are like the opposite operation. This is why sometimes integral is called antiderivative. By the way, antiderivative means the result of integral. Integral of any constant, we just add an x next to it. Like integral of 2 is 2x. Integral of 3 is going to be 3x. And there is always plus c. So let's repeat quickly. When x has power, the integral will be power plus 1 over new power. Like, guess the integral of x power 4. Integral is x power 4 will be x power 5 over 5, and there is always plus c. Integral of 0 is c, that's a rule. And integral of any single number, any constant, the number stays the same, we only write x next to it. Okay, check out. What is the integral of x power 3? Obviously, x power 4 over 4 plus c. Alright. Sometimes in integral questions, the question says, find antiderivative. Underline antiderivative. Antiderivative means result of integral. Again, when a question says find antiderivative, you need to solve the integral. The result of the integral is called antiderivative. So antiderivative is result of integral. Now I have x power 2, so I should do integral x power 2 dx. Then the integral of x power 2 obviously is x power 3 over 3 plus c. Whenever you see a point given in a question and it's asking for antiderivative, the purpose of this point is to find c. Let's read it out. c, x power 2 becomes x power 3 over 3. Zoom in. X power 2 becomes x power 3 over 3 plus c. A point is given to help you find the value of c. Okay? The point is given 3, 3. This 3 input, it's x. The other 3 is output, it's the result. Okay? Now, in this integral, I'm going to write 3 in place of x and equalize the result to 3. So 1 3 is input, the other 3 is output, means the result. Then instead of x I have 3 power 3 over 3 plus c equal to 3. 3 power 3 is 27 divided by 3 equal to 9. 9 plus c equal to 3. 9 to the other side. 3 minus 9 equal to c. Negative 6 equal to c. Once I found the value of c, I'm going to write the integral again, but instead of plus c I write this value, which is negative 6. So fx, result of integral, we write it with capital letters. Fx equal to x power 3 over 3. Instead of plus c, I have minus 6. This is the antiderivative for the function f small x, which is the normal function, that was x power 2, which was given right here. The function was x power 2. So integral of f small is going to be f capital. That's only if you know, it's good. If you don't know, it's fine. For multiple choice, it's not a big deal. Now again, I have x power 4, I have this point given. Integral of x power 4 is going to be x power 5 over 5 plus c. Replace x with 2, equalize the result to 4. That would be 2 power 5 over 5 plus c equal to 4. Now to find the value of c, I send this to the other side. C equal to 4 minus 2 power 5 over 5. And you can write this in calculator to find the result as a fraction. 4 minus fraction 2 power 5. Now you might say this calculator is not allowed in the exam. Yeah, I know that. The result is negative 12 over 5. But you can write this in your own calculator this way. See, the way your calculator understands is like this. You write 4 minus bracket 2 power 5 divide by 5. Once you press equal, you will get the same answer. Firstly, you get the answer as decimal, and if you press shift ABC, you can get the answer as fraction. And yeah, this is complete. Here I wrote some examples. Such examples, such questions have been in Wizari a lot. Any example you see, it's identical or its form have been in Wizari. This is why I wrote it here. Now let's write some of them and solve them properly. Let's write some of them. Okay, I have integral x power 3 over 2 dx. I want to solve this. And there's integral x power negative 3 over 4 dx. Let's solve these two for now. Starting with the first one, integral is always power plus 1 over new power. X power 3 over 2 plus 1 is going to be 5 over 2. 3 over 2 is 1.5. Plus 1, it will be 2.5. 2.5 is 5 over 2. And divide by the new power over 5 over 2. Since the power is fraction, I don't manually write over 5 over 2. Instead, flip the fraction immediately. That saves time. This is already the simplest. So x power 5 over 2, and here I write the reciprocal, 2 over 5 plus c. This is the integral. Later we learn how to simplify this. X power 5 over 2 is no simplest form. Let's do this. Again, negative 3 over 4 plus 1, power plus 1 over new power. Negative 3 over 4 plus 1 is going to be 1 over 4. So the result will be x power 1 over 4, and here 4 over 1 plus c. Anything over 1 stays the same. Now I have 4x power 1 over 4 plus c. Simplifying, this is x power 1 under quartic root. So 4 quartic root of x plus c. This is the final answer in the simplest form. Now, to simplify this, it's going to be 2 over 5. That's x power 5 under square root. But if I write 5 over 2 in calculator, calculator says 2, 1, 2. If you write 5 over 2 in your calculator, you're going to see 2, 1, 2. The first 2 literally means a whole number, 2, and the 1 over 2 means 0.5. So 5 over 2 is equal to 2.5. Now, how can I manage this? The first 2 means x power 2, and the 1 over 2 means square root x. And don't forget the c. This is the simplest form of this antiderivative. Antiderivative means result of integral. That's complete. Okay, let's solve this one. 5x power 1 over 2. Whenever you see a constant, 5x power 1 over 2 positive dx. Constant or whole numbers stay the same. Multiplication of a constant stays. Multiplication stays in division and in integration. So the 5 stays as it is. X power 1 over 2, 1 over 2 plus 1 is going to be x power 3 over 2, and here 2 over 3. This 5 is next to the fraction. It is multiplication, stays multiplication, and there's always plus c. Simplify. 5 times 2, 10 over 3. X power 3 over 2, write in your calculator 3 over 2. The calculator says 1, 1, 2. This 1 over 2 is square root x, and this one alone is x power 1. So these are powers. This is x power 1, and this is x power 1 over 2, which is square root x. Now, instead of x power 3 over 2, I can write x square root x, and there's always plus c. These examples are all okay. Nothing so special. It's repeating the same idea. Here we have x in the denominator. If we have x in the denominator, we cannot do the integral. Then what we do, we send x up. For example, if I have 1 over x squared dx. This integral I cannot do it directly. Then what do? I need to rewrite. Let's write. Rewrite. Then how is the rewrite? Same function. Integral is not complete yet. X is in the denominator. When we send it up, power becomes negative. X power negative 2 dx. Now to do integral, we have one rule for x with power, which is power plus 1 over new power. Result is going to be x power negative 1 over negative 1 plus c. This is not simplest form. If the power of x is negative, that's not simplest form, then the x with the power should go down, then the power becomes positive. Nothing remains up, that's just 1. X power negative 1, when it goes down, it becomes x power positive 1, which is not necessary to write. And there's a minus down. Having minus in the denominator again is not the simplest form, so I can write the minus here, or I can write the minus here. They are both okay. So I just write the minus up, and the plus c stays as it is. This is the answer. Now how can I check my answer? Now if I take derivative of this function, I should get this back. Let's check. What is the derivative of negative 1 over x? Then the derivative will be power of x is 1, negative stays, 1 multiplied by negative 1, x power plus 1 will be 2. So the result will be negative negative, just 1 over x squared. And if you notice, 1 over x squared is the same as this one, 1 over x squared. So result of integral, if we take derivative of it, we will get what is inside the integral. So derivative of this is going to be 1 over x squared. What happened to the c? C is a number, derivative of number is just 0. We can ignore c. More questions. Now we're going to write some rules about trigonometrics. Integral of sine x dx is going to be negative cosine x plus c. Before, if you remember, the derivative of cosine was negative sine. Now it's time to revenge for sine. Integral of sine is negative cosine, and integral of cosine x dx is just sine with no negative, plus c. Tan has two possible integrals. One of them integral of tan x, tan square x plus 1. That is the derivative of tan. If I do integral, which is antiderivative, I'll get the tan back, tan x plus c. And also integral of 1 over cosine squared x dx is going to be tan x as well, plus c. So far for trigonometrics, we have these 4 rules. Now look at this. This 2 is multiplication, stays the same. So I have cosine, integral of cosine is just sine, so the 2 stays, 2 sine x. Minus stays the same, 5 stays the same, integral of x power 1 is x power 2 over 2 plus c. And luckily this function is already in the simplest form. Let's do this. The 2 stays as it is. Integral of sine is negative cosine x, plus 3 stays the same. X power 2 is x power 3 over 3 plus c. There is cancelling. Final answer, negative 2 cosine x plus 3 cancels 3, x power 3 stays the same, and there's always plus c. Now we have some integrals to do. As we said, x power 3 in the denominator, we need to rewrite integral x power negative 3 dx. Now complete. To do the integral, we just say power plus 1 over new power. Negative 3 plus 1 will be negative 2. Divide by negative 2 plus c. Simplify. X with a negative power is not simplest form. It should go down. The power will be positive. And having one negative like this in the denominator is not the simplest form. We send the negative up. After the x power negative 2 leaves the numerator, nothing remains. And for such cases, we need to write 1 because we cannot write a fraction with literally no numerator. This one, square root x, I can write it as x power 1 over 2 because the x is power 1 and there's square root. Dx, the integral will be power plus 1 over new power. X power 1 over 2, 1 over 2 plus 1 is going to be x power 3 over 2, and here flip the 3 over 2, 2 over 3 plus c. Simplifying, if you write in your calculator 3 over 2, you are going to see 1, 1, 2. The first one is x power 1. The 1 over 2 is square root x. So that's 2x square root x all over 3 plus c. Now we have multiplication. This idea is very, very common. What we do, multiply. Integral, the first x is power 1, the second x I can write it as x power 1 over 2 dx. You know, in multiplication we need to add the powers, and if we add the powers it's going to be x power 3 over 2 dx. Until now I am simplifying the terms inside the integral. I did not do the integral yet. So I'm not allowed to say x power 3 over 2 over 3 over 2, no, because the integral sign is still there. I did not do the integral yet. I'm only multiplying and simplifying the terms inside the integral. So we can do the integral now. No more integral sign. 3 over 2 means 1.5. If we say plus 1, it will be 2.5. And make 2.5 fraction. Calculator shows you 5 over 2. 5 over 2 means 2.5. And here flip it, 5 over 2, 2 over 5, plus c. 5 over 2 is not simplest form. If you write 5 over 2 in calculator, you're going to see 2, 1, 2. The first 2 is going to be x power 2. The 1 over 2 is going to be square root x, and there's 2 here, all over 5 plus c. Look at this note. I wrote the simplest forms for radical and fractional power terms. See, if you have square root x, we can replace it with x power 1 over 2. If we have x power 3 over 2, I can write in calculator 3 over 2, and I'm going to see 1, 1, 2. The first one is going to be x power 1, and the 1 over 2 will be square root x. So if I write 3 over 2, I will see 1, 1, 2. The first one is just x power 1. The second 1 over 2 is square root x. This one is not necessary to be written, so it's x square root x. Yeah, we already did these. Yeah. Okay, here we have some good questions. These are about derivative of inside. Let's solve the first 3. The first 3 are like this. Integral 2x minus 5 squared, integral x minus 2 x plus 3, integral x 2x minus 5. Now let's do these integrals. Firstly, for every bracket with power, derivative of inside is the key to solve the integral. What is the derivative of inside for the first integral? The derivative of inside is just 2. If I have the 2 outside, that's good luck. If I don't have, I need to make it myself. Now I don't have 2 outside, I write 2 here. Since I wrote this 2, which was not originally here, to keep the balance I need to write 1 over 2 outside. Now remember, the derivative part or the derivative of inside always gets cancelled. Then why did we write in the first place? We wrote it to cancel it, okay? It's fine. Derivative of inside is 2. I did not have 2 outside, so I wrote 2. And to keep the balance of 2, I wrote 1 over 2 outside. This 1 over 2 outside stays. Nothing can cancel it. While the 2 itself is the derivative of inside. The part which is derivative of inside always gets cancelled. Then what do? The 1 over 2 stays, and the whole bracket all together, we say power plus 1 over new power. 2x minus 5 power 2 will be power 3 over 3 plus c. Simplifying, 2 times 3 is 6. That is 2x minus 5 power 3 over 6 plus c. Look at the second one. Since I don't have derivative of inside outside and I have 2 brackets, I just have to expand, then do the integral of each term separately. X times x, x squared, x times 3 plus 3x, negative 2 times x minus 2x, negative 2 times 3 minus 6 dx. Now do integral of each one separately. Let's simplify it a little bit more. Equal to integral x squared plus x minus 6 dx. Now I can do the integral. Integral of x squared is x power 3 over 3 plus integral of x is x power 2 over 2 minus 6 will be minus 6x, and there is always plus c. Now this integral, derivative of inside is 2. There is one extra x. I don't have the derivative of inside available. Then I multiply this x by inside. Once I do that, I get integral 2x squared minus 5x dx. Now integral of each term separately. 2 stays the same, x power 2 will be x power 3 over 3 minus 5 stays the same, x will be x power 2 over 2, and there's always plus c. Now we solved these three integrals. All of them are good questions. Now we have ln. When the result of an integral become ln, the result will be ln if you see x power negative 1. Whenever you see x power negative 1, we cannot say power plus 1 over new power. If you do, you are going to write x power 0 over 0. That is wrong. This is not right. Then what is the right one? The right one, x power negative 1, will be ln x. How? X power negative 1, I can rewrite it as 1 over x. And if you remember, derivative of ln x is 1 over x. That means integral of 1 over x is going to be ln x. It's the opposite operation. It's the reverse process. Derivative of ln x is 1 over x. Integral of 1 over x is ln x. There's always plus c. And writing or not writing dx for such questions is not a big deal. Now look at question 1, 2, 3, 4. Let's take them to the notebook and solve them separately. This 2 is extra. The rest are okay. Whenever you see a fraction, first think about ln. Now, I have this 2 extra, I can send the 2 outside the integral, then I have 1 over x dx. I already know integral of 1 over x is ln x, and the 2 stays. 2 ln x plus c. Now question 2. Let's send negative 5 outside. Integral 1 over 1 plus x dx. Derivative of the denominator, derivative of 1 plus x is just 1. And since I have the 1 up available, then I can just ignore the derivative part, ln of denominator. And eventually we write the ln inside absolute value, so to prevent ln having negative numbers input. Now this will be ln absolute 1 plus x, and there's always plus c. Question 3. The negative 4. By the way, this negative 5 stayed, so I write here negative 5. Negative 5 multiplied by ln absolute 1 plus x plus absolute plus c. This is the answer. Now question 3. Let's do question 3. Question 3. Send negative 4 outside. Integral 1 over 1 minus x dx. Derivative of the denominator is negative 1. And there are two things I can do. I either bring this negative back inside, or I can just add a negative inside to maintain the availability of the derivative of denominator. If I add a negative inside, then I have to add a negative outside to keep the balance. In this case, negative outside cancel out, it becomes positive 4. And this negative 1 is the part which is derivative of inside. We just ignore it, and then it will be ln absolute value denominator. And there's always plus c. We can do it this way. Question 4. Again, derivative of denominator should be available in the numerator, then it will be ln. Now I have integral x squared plus 2, and I have 2x up. What is the derivative of x squared plus 2? Derivative of x squared plus 2 is just 2x. Since the 2x is available up, the 2x's derivative part, it will cancel out. Then the result will be ln denominator, ln absolute x squared plus 2, and there's always plus c. What if I don't write absolute for this question? Since x squared plus 2 is always positive, then it's okay to not write absolute, write only normal brackets. It's totally okay. Now we got the idea of ln, and we have trigonometrics. Again, in trigonometrics, the part which is called derivative of inside is very important. This thing should exist, then the integral could be completed. These are all extra examples. I wrote them, and there have been questions similar to these in those areas. Let's take them and solve them in the notebook. Okay, we need the questions. Writing dx or not writing dx for multiple choice questions is not a big deal. The ideas, how can we solve them? Number 1, sine 2x. What is the derivative of inside the sine? 2. Do I have 2 outside? No. I need to write here 2, 1 over 2 outside to keep the balance. Remember, the derivative part always gets cancelled. The 1 over 2 outside stays. Integral of sine is negative cosine. The angle, which is 2x, never changes. This is the integral, and there is always plus c. Now simplifying, this will be negative 1 over 2 cosine 2x plus c. This is the result. Now look at question 2. Derivative of inside is 5, but I have a 3 outside. This 3 outside stays outside, doesn't interfere at all, stays until the end. So question 2, the 3 stays, integral sine 5x dx. Derivative of inside is 5, I wrote here 5. To keep the balance of this 5, I write outside 1 over 5. Now, this 5 is the derivative part, it will cancel out. But this 3, this 1 over 5 outside stay. That's going to be 3 over 5. Integral of sine is negative cosine, and the angle never changes. There's always plus c. Number 3, derivative of inside is 2. It is available outside. The 2 gets cancelled immediately. Integral of cosine 2x is just sine 2x. 1 over cosine squared will be tan, but if the derivative of inside is available outside. Integral is all about derivative of inside. Whenever derivative of inside is available next to the function, then the integral could be completed. Integral cosine squared negative 2x dx. The derivative of inside is negative 2. I need to write here negative 2. This negative 2, I wrote it. It was not originally here. Then I need to keep the balance by writing 1 over negative 2 outside the integral. What happened to the 1? 1 times anything is the same. So negative 2 times 1 is just negative 2. Now, since the derivative of inside is available outside, the derivative part gets cancelled, and 1 over cosine square will be tan, equal to negative 1 over 2 stays. That is tan, angle never changes, negative 2x, and there's always plus c. Another example is question 5. Negative 4 over cosine squared negative 3x. Derivative of inside is negative 3, so I can take the 4 outside, only the 4. Integral, the negative stays. Okay? Or if it feels confusing, Take the whole negative for outside, it's okay. Derivative of inside is negative 3x. The negative 3x, the derivative is just negative 3. Cosine squared negative 3x. I added this negative 3, it was not originally there. Then outside, I need to add 1 over negative 3, and later I'll multiply dx. The derivative part goes away. 1 over cosine squared is tan negative 3x. The angle never changes. There's plus c. And negative cancels negative. This is 4 over 3. So this is the result of the integral for question 5. Now question 6, 1 plus tan squared is also going to be tan. But again, the derivative of inside should be available outside. By derivative of inside, I mean derivative of inside the bracket should be available outside. Now this 2x, derivative of 2x is just 2, and write 1 over 2 outside. This 2 gets cancelled. 1 plus tan squared will be just tan. 2x stays 2x, no change. And don't forget the 1 over 2 outside plus c. Okay, what happened to the 1? 1 plus tan squared by itself is the derivative of tan. That means integral of 1 plus tan squared is just tan. 5x minus 7 sine x. That's a very ordinary question. 5x will be 5x squared over 2 minus 7 sine will be 7 stays the same, negative cosine x plus c. Negative negative will be positive, 5x squared over 2 plus 7 cosine x plus c. And finally question 8. What is the derivative of inside? Derivative of inside is this fraction, 2 over 3. Integral, and I write 2 over 3 here. 3 over 2, which is the reciprocal, I write it outside. Now the derivative part gets cancelled. Cosine will be sine, angle never changes, and the 3 over 2 outside stays there, and it will exist until the final answer. And there's always plus c. These examples are really good examples. Now we have exercises. The exercises are very easy. These exercises are about antiderivative. So you should take derivative of the result, and if you got these same functions back, means the integration is correct. If you did not get these back, by finding derivative of the result, we need to get these back by finding derivative. If we got what's inside the integral back, then the integration is correct. If we did not get these back, then the integration is incorrect. These are all easy questions. We already solved identical to them. Question 6 is a great question. Whenever you see power for a number and x, the power equally goes to both of them. So this is going to be integral 1 over 9x squared dx. And to do the integral, I can send x squared up. It will be integral x power negative 2 over 9 dx. This over 9 is division. It stays even in the answer. The over 9 stays, and x power negative 2, the integral will be power plus 1 over new power. Negative 2 plus 1, negative 1 over negative 1. Let's write the result. This will be x power negative 1 divided by negative 1, and there is already 9 in the denominator plus c. X power negative 1 is not simplest form, and having negative in the denominator is not simplest form as well. Then it will be negative 1, 9x in the denominator plus c. X power negative 1 goes down, becomes x power positive 1. The 9 is already down, stays down. This negative is in the denominator, it's not simplest form, so it should go up. Nothing remains up, we should write 1. This negative 1 is not this negative 1 that went up. No. Nothing remains up, I can write 1. The negative should not stay in the denominator, it goes up. And then x power negative 1 goes down next to the 9. The 9 is already down. These questions are all quite basic. Question 9, make this x power 1 over 2 and send this radical x up. It will be x power negative 1 over 2 and there is 2 down. Then do integral of each one separately. The result will be like this. In this list, let's solve question 10. To solve question 10, we can apply partitioning, or we can change the radical x to x power 1 over 2. This will be x power 1 over 2. When we send it up, it will be x power negative 1 over 2. Multiply this by all the 3 terms. In multiplication, we add the powers. We'll get something like that. Then apply the integral. For each term, power plus 1 over new power. 3 over 2 plus 1 is 5 over 2, 2 over 5. X power 1 over 2 plus 1 is 3 over 2, 2 over 3. X power negative 1 over 2, negative 1 over 2 plus 1 is x power 1 over 2, 2 over 1. Integration is easy. Tan square plus 1, it will be just tan. It's a rule. Section 1 is all about these. Now we have one derivative. We need to find two functions where we do derivative for them. We get the result of 2. Since y equal to 2 is the derivative, integral of 2 is 2x. I write two functions containing 2x. This is 2x plus 6. This is 2x minus 2. And if I do derivative of each one, I will get 2, which is the required one. This line is the line of y equal to x. Integral of x is x squared over 2. I write two functions containing x squared over 2. This one is x squared over 2 by itself, and this one is x squared over 2 minus 5. If I do derivative of each one, I will get x. Y equal to x is the equation of this line. I'll get the x back. And here, the function itself is negative x squared plus 1. Negative x squared plus 1. This is the equation of the function. It is negative quadratic and it went up 1 unit, so it is plus 1. If I do integral, negative x squared will be negative x power 3 over 3, plus 1 will be plus x. Now I need two functions containing negative x power 3 over 3 plus x and negative x power 3 over 3 plus x minus any other number. Let's say 3. This type of question is very, very common. The question gives you a derivative and a point. It's asking for the original function. Okay, how do we go back from derivative to the original function? By taking integral. What is the integral of 2x? It will be 2x power 2 over 2. 2 cancels 2, just x power 2. It's like 2x power 2 over 2. The 2's cancel out, only x squared remains. Negative 1 will be negative x, and there's always plus c. You know already if a point was given, we use the point to find the value of c. Replace x with 1, equalize the result to 1, we will get this. 1 squared minus 1 plus c equal to 1. 1 minus 1 plus c equal to 1. This will be 0, 0 plus c, c equal to 1. Once I find c, I write the function fx completely. Instead of x, I just write the value I found, which is 1. Question 20. Firstly, we multiply the 2 by inside. Then we get that. Integral of 2x is x, 2x squared over 2 to cancels out. X squared remains. Integral of minus 2 will be minus 2x plus c. Then 0.32 is given. Replace every x with 3. Replace the result, which is y, with 2. We get that. 3 squared is 9. 2 times 3 is 6 plus c equal to 2. 9 minus 6 is 3. 3 plus c equal to 2. Send 3 to the other side. C equal to negative 1. Once we got the value of c, we write the result of the integral, but instead of c, we write the value we found, which is negative 1. For this lesson, this is enough. Next lesson, inshallah, we start on plants growth and we'll finish chapter 5, section 1. Hope that helps.